So for question 39a, it says write each vector in terms of the unit vectors I hat and j hat. So first thing we're going to need to do is to solve for this triangle and that triangle. So I'll rewrite the triangles. 70 plus 90 is 160, so that's 30. And we know this length is 3.6. So now we just need to solve for this using the law of sines, which is the sine of 90 divided by 3.6 is equal to the sine of 30 over this length. We'll put that as x over x. So now we just need to solve this problem for x by multiplying x across and multiplying 3.6 across. Sine of 90x equals the sine of 30, 3.6. Next, you just divide the sine of 90, which is 1. So you divide this by sine of 90, or 1. So now we have x equals the sine of 30 times 3.6. And that comes out to be 1.23. So now we know that that is 1.23. Next, you're going to try to solve for this. We'll make it h. So you're going to do the same thing, but with sine of 70 instead. So h equals sine of 70 times 3.6. And that comes out to be 3.38. So h equals 3.38. We just solve for that triangle, and then you would do the same thing for this triangle. So now that I've solved both triangles, I can write each vector in terms of the unit vectors I hat and j hat by doing this. Vector A is equal to 1.23, because that's I hat, plus 3.38 j hat. And we can do the same thing for B. But this is going to be a negative 2.08 because it's going in this direction, which is negative. So it would be a negative 2.08 I hat plus a negative 1.2, negative 1.20 j hat. And that's your solution. So 39b says use unit vectors to express vector c, where c equals 3 times a minus 4 times b. So what it's basically saying is 3 times a, so first thing we're going to do is multiply both of these numbers by 3 and both of these numbers by 4. So I'll rewrite that over here. So the equation for c is 3 times a minus 4 times b, as we wrote over here. I multiplied this number by 3 to get that, as well as this number by 3 to get that, and 4 for these two numbers. Now to find c, what we're going to do is take a minus b, so we'll take I hat from a and subtract I hat from b, which gives us 12.01. Because you're subtracting a negative number, so you add it. And then as you subtract the negative 4.8 from 10.14, you get a positive 14.94. So these are now our I hat and our j hat for C. And now what we do with these two numbers is we're going to create a triangle. Essentially what we're doing is adding the two vectors together. So if you remember from part A, our first vector, A looked like that, Our second vector was b from that. So because we're subtracting, we're going to flip this around and then bring it right up here and add them together. So this now becomes vector c. And we now know the angle for vector c, the I hat is 12.01, and the j hat is 14.94. Now, we just use the simple Pythagorean theorem, and we can figure out what c is. So when we use the Pythagorean theorem to find the hypotenuse of c, we get 14.9 squared plus 12.0 squared equals 366. Take the square root of 366, and we get 19.1, which is the hypotenuse right here. And that is also our magnitude for c, equals 19.1. And now to find the direction, which is this angle right here, we're going to take the cosine of this, which is the cosine of theta, which is adjacent over hypotenuse. So we're going to take the adjacent and put it over the hypotenuse. Now all we got to do is take the inverse cosine of both sides. And we get theta is equal to 51.3 degrees. And that is the direction for theta.